or that my slides would be messed up. All right, so we're going to have some small titles. That's okay. So I'm talking about mapping the open source ecosystem for climate science and sustainable tech. I wear a lot of hats. Many of you may know me from other places. So I'm a PhD student at Victoria University of Wellington, Te Herenga Waka in Pōneke, Wellington, New Zealand, Aotearoa, New Zealand. But I'm also an organizer for Curious, which is University OSPOS. I'm also an organizer for the past 8 years for Sustain OSS. I've been running a podcast on sustainability and the sustainability of FOSS projects with like 400 episodes. And I fell in with these horrible people, none of whom could make it today. One of them tried, Alex. I hope you're doing okay. Alex got COVID, so couldn't make it. Everyone else is just in Europe, so, you know, who cares? No, they're all really nice. I want to point to one name in particular. Tobias Augsburger is really the power behind this project, and we'll see why in a minute. But it's about opensustain.tech. So why are we talking today? Just to be clear, why you're listening to me. Well, it's because we're all screwed. The climate crisis is evident. It's going to happen immediately, and there's nothing happening about it. COP was a disaster, and that sucks. All of us, though, are idealists, and we're all optimists. We're all trying really hard to have open source change the world, to reduce extra effort, to make sure that we have technological solutions to real systemic problems. So that's really, really great. What I'm trying to present today is the largest human-curated data set of open source projects for the climate crisis. So the idea is, hey, let's work together on the biggest problem that we have to face. So even though it's doom and gloom, these might be the tools that can help us get away from that to some other noun that sounds like happiness but ends in I can't think of one. Who are we? Well, there's me. I already talked about that. And then there's Alex, who worked a lot at Wikimedia and also was from Uruguay, and so it would have been great to have him here to talk about the Global South. I'm really happy to be here in the Global South talking about this because the Global South is disproportionately affected by climate change. Also, for those of you who speak Portuguese in the room as a first language, I am sorry that I talk so fast. Your coffee is very good. The problem is the climate crisis is here. I just said this, so I won't deal with it. One thing I will say is that governance alone won't solve the problem. We need tech solutions as well, and we need social solutions. We need to work together on things. We can't rely on our governments. I'm American. We can't rely on our governments. Open work can generally help. If I had thought ahead, I would have used the open definition, which was probably better than this. But just open work in general. So open organizing, open science, open data, all the open things, especially open windows when it's really cold. Open source is really great. We've just talked about open source for a long time, so I don't need to dwell on this. But basically, GitHub is a major player. 90% of software in the world is using open source at the moment. 97% according to one stat by Black Duck, which is a security firm that probably actually has an interest in inflating that number. And then there's the Nagel paper, which is absolutely incredible. Don't focus on the 9 trillion. I think the 4 billion number is a lot more meaningful in that paper. But open source is everywhere. Cool, we all know that. That's why we're all here in Brazil, great. In climate science, it's really hard to tell where open source is. And it's hard to tell for a few reasons. One of them is that a lot of DPGs are kind of platform level and not necessarily dependency level. So you can have a DPG that uses open source, but it's hard to say what open source they're actually using. It's just sort of, yeah, we're open. Another reason is that big tech is not incentivized to release open models. We've seen this for AI. They're like, no, it's all private, it's cool. Here, it's open now. And there's definitely open washing, looking at you, Facebook. And then governments in general are really bad at this stuff, mainly because people who go into government aren't people who go into making ISPs. They're like different sets of people, which is kind of a shame. DPGs may help, and I hope so, and that was a great talk, so thank you for that. Open Sustain Technology is how we're trying to fix this. So it's a website, it's a community-driven project. It was started by Tobias in 2020, and it's a diverse team. I wish we were more diverse on certain axes. You may have noticed all of our authors were basically white European men. I'm not happy with that, but we're diverse in other ways in our roles. And we've had some collaborations with the Linux Foundation and GitHub, which is great. It's basically a giant list of projects, and it was really hard to make that list of projects, and I'll get into the stats in a minute. It was hard because there's no internet-wide search engines for open source. There's a really good paper by Katie McLaughlin, Amanda Casari, I think Juniper Lovato, on the penumbra of open source. A lot of open source is actually outside of GitHub, and it's harder to find that. The other issue is that it's really hard today to find anything because AI is horrible. It's just horrible. It's screwing up all our search engines. It's good for other things. It's great for like making slides. Another issue is the polysemy, which is another word for pun. But really, you know, the cloud could mean clouds or it could mean the clouds. Climate is now used all over the place for things like Docker. But like, I'm trying to talk about the climate. It's really, really difficult to search for good technology these days. And there's a lot of bad projects online. There's so many GitHub accounts that only have Computer Science 101 test homework. And it's like, thanks, that's open source, cool. But maybe it's not as useful. And there's no standardized protocols because we can't agree on things, which is hard. So our solution to that was, let's just do it the hard way. The Norwegian library was awesome for saying that, you know, everyone wants data, but no one wants to do the data work. So whoever said that yesterday, thank you, that was a brilliant quote. We figured let's just do it, you know, by humans. Let's just go through and say, oh, I found this. Excellent, let's add that. Let's make it in Markdown so we make it really easy. Let's make the PR system on GitHub do the work for us. So we don't have an Excel spreadsheet, we just have a PR system. And let's use a rubric to identify what we have. Here's our criteria for our list. A, does it have an OSS license as approved by the OSI? Personally, I don't like that definition, but it works pretty well for most purposes. B, does it demonstrate usage and goals that are relevant to environmental sustainability? Technically, every ISP that was mentioned in the last talk is relevant to open source, to climate, because climate is an intersectional issue. So anything that brings up other people is going to be related to climate. But for us, we're like, no, it has to be a direct link. How is it directly linked? Is it active? Are there citations, or is there general use? And is there documentation on how to reuse it? Because otherwise, it's kind of not very useful. We have these various sections that we use to, you know, diagnose where a project should be. Sometimes they should be in multiple sections, but we only really use one. I don't know why we have natural resources and also natural resources, but let's not think about it. Basic stats, we have 2,500 projects, which is actually a lot when you consider that this is all done by hand. Alex Pierre Stinson, who is Pierre Vogel, I should have learned his last name, who is one of the co-authors, has an AI project that has a lot more, where he went out and found a lot of open source projects, but they're not as good because they haven't been hand curated. The major issue is that Tobias contributed everything. Tobias is one of these incredibly dedicated Germans who just really likes doing work and then saying, no one else does the work. Why are they not doing the work for me? And I'm like, I'm sorry, Tobias, I'm sorry. Here are the programming languages we have. Python is amazing. Everyone in climate science loves Python. R is really cool. I personally hate the stat that R is number 2, and I don't like it because R uses CCAN as our package manager, and CCAN says you don't include the license file with the repo, but the licenses for most open source says you have to include the license file. So CCAN is violating the license for every single package, which is one of the things where once you drill down into the data, you're like, is this even open source? Sorry, that's just an axe I had to grind in public. Thank you for listening. Number of contributors for most of our projects, somewhere between 5 to 10 is like most of our projects. It's pretty cool. That means if we have 2,500 projects and you assume that they're not duplicative, that's actually a lot of people working on climate science. Generally, projects have been around for like 3 years. Some of them have been around for almost 20. The fact that it takes a while for projects to go up may just be a fact that it takes us a while to find them, but it may also be that it's hard for projects to like be found, right? It's hard for adoption to happen. So as a field, we could help adopt open source better. And we could do it in these different areas. I'm realizing with this lighting, this is not as pretty. We have much prettier dashboards online, which you can zoom in. Command plus, everyone. Andrew Nesbitt is another, I'm not even looking at the time. Andrew Nesbitt is another one of our co-authors, and Andrew is my favorite person ever, not only because he has 4 poodles. He runs ecosystems, so ecosystem.ms, you can look up that URL, and it is the largest database of packages because it includes every other package manager. It is amazing. Those are actual numbers from the website. And so I'm like, hey, can we show the use of our packages? And Andrew's like, of course, I'll have it tomorrow. Amazing. So generally, 27,000 projects, which are other open source packages, not top level platforms. These are packages. There's a difference. Remember, a lot of DPGs are like, here's an entire thing. Signal is an entire thing. Our code is working on all the dependencies for Signal. So 25,000 projects use our projects, which is great, which means maybe there's more we should add. There's like 7,000 repositories that use them. Some of the projects on our list, 370 of them, which 370 divided by 2,500, no, maximize is like 12. Yeah, it's 12. Whoa, no, I'm not going to do math, live math. I apologize for live coding. That was a mistake. Let's just move on. I'm embarrassed. Another cool thing that Andrew did was made a science score. So he's like, for these packages, how many of them are actually academic? How many of these open source dependencies are being used and made with the idea of publishing them somewhere? I can see your eyes glaze over. I would too. But this is really cool. This is really cool data. So what we have is like, a lot of the projects have a Zenodo file, which means that they're actually interested in being researched. A lot of them are in JAWS. 7% is pretty great. The Journal of Open Source Software, if you haven't heard of it before. 13% have citation.cff. This is a travesty. Tragedy. Travesty means something else. All of them should have citation.cff files. You should cite all of your software if you're an academic. Come talk to me about that later. But yeah, I just thought these were really amazing stats. The fact that a third of them have DOIs is excellent. So that's really cool. And that's actually basically my talk. We have 2,500 packages. We think they're really cool. We think they're all useful for science. We think they're all useful for the science of keeping us alive in the future, because that's what the climate crisis means. It's not like, oh, I'm going to get a ticket. It's like, no, the ticket system will be gone, and so will you. So you should use this stuff. I came here to talk about this with you because I think it's really relevant that we think about, oh, what open source tools are for the most important problem. Now, all of you may be feeling like, wow, that's way too much pressure. That's okay. Just go to the website and say like, huh, that's interesting, and then share it with like one friend. That would be great. I'd be very happy. What else did I say I was going to talk about? I tend to ignore my slides. I'm sorry. Yeah, the economic argument is another thing I would really love to figure out. Cool, there's 2,500 packages. How much does that actually change the numbers? How much does that influence policy? How do we know how to maintain all those packages? What would it cost? You mentioned a trivial number yesterday that would it cost to do AI for like a whole country. What would it cost for us to fund all the people behind those 2,500 packages? That's not a lot, right? $1 billion? $1 billion to help out the climate? That sounds pretty good to me. So that's kind of something I want to talk about here, and I would love to have any information on how to make that better. We have our long paper on the Zenodo. Please look at it. And you can always email us. You can join us at opensustain.tech. Pretty easy. And I guess that's it. I thought I had a goodbye slide, but email me. Be in touch. Thank you very much.